In this video, we're going to look at the learning target. I can solve quadratics in vertex form by taking the square root of both sides. So when solving a vertex form equation, basically what we're going to do is we're going to get whatever stuff is being squared by itself. And then once we get the stuff that's being squared by itself, we're just going to take the square root of both sides and then simplify from there. So if I look at number one, you'll notice I have 2 times the quantity x minus 1 squared plus 9 equals 63. So the first thing I'm going to do is try to get this part of the equation by itself. I want the x minus 1 because it's being squared. I want that by itself. So to do that, I'm going to start by subtracting 9 from both sides. That's going to eliminate the 9 on the left side, and I'll have 2 times x minus 1 squared on the left. And then I'm going to take 63 minus 9, which gives me 54. Then, once I have 54, I'm going to divide by 2 to both sides. That's going to cancel the 2's, and I'm left with x minus 1 squared equals 54 divided by 2, which is 27. And then to get rid of the square, I can take the square root of both sides. Square roots and squares will cancel each other. So the square and square root are inverses. And I'll get x minus 1 equals the square root of 27. Now, I need to simplify the square root of 27. Okay, so I need to break this down further. So when I do that, x minus 1 is going to equal, and I need to think about what perfect squares go in to 27. So if you think about your perfect squares for a second, you have 1, 4, 9, 16, 25, 36, 49, and so forth, right? And so I want to find the biggest perfect square that's going to divide evenly into 27, and in this case, it's going to be the 9. So I can rewrite the square root of 27 as the square root of 9 times the square root of 3, right? Because 9 times 3 is 27. And then when you think to yourself, what number squared gives me 9? Well, that's just 3, right? So I get x minus 1 equals plus or minus 3 times the square root of 3. Now, I'm going to talk about why I wrote plus or minus for a second. The reason why I wrote plus or minus is because if you take 3 and you multiply it by itself, 3 times 3 gives me 9. And if I take negative 3 times negative 3, well, that will give me 9 as well. So because both the positive and negative work, I need to include both. So I have a plus or minus on that answer. And then the last thing I do now that I've simplified the square root is I just add 1 to both sides. So I get the answer x equals plus or minus 3 times the square root of 3 plus 1. These are not like terms, so I cannot combine them. Okay, I leave my answer as this mess, so to speak. Okay, it is the square root, or it is plus or minus this 3 times the square root of 3 plus 1. Okay, there's no combining here because they're not like terms. All right, let's look at another example. So if I look at number 2, I have 3 times the quantity x plus 4 squared minus 5 equals 10. And once again, I want to get whatever's being squared by itself. So I would start by adding 5 to both sides. That's going to give me 3 times x plus 4 squared equals 15. And then I'm going to divide by 3. The 3's will cancel. I'll be left with x plus 4 equals 15 divided by 3 is 5. And then to get rid of the square, I simply just take the square root of both sides. Okay, the square and the square root will cancel, and I'll be left with x plus 4 equals, and then notice that the square root of 5 can't be simplified, but I need to remember that I can have the plus or minus of each of those, right? Because positive 5 squared will give me the 5 back, and negative 5 squared will give me the 5 back as well. So I want plus or minus of both, and then I'm going to minus 4 at the end. And so I get x equals plus or minus the square root of 5 minus 4 as my answer. All right, let's look at two more examples here. So at number 3, I have 2 times x squared minus 9. And notice this time only the x is being squared. So I just want to get the x squared by itself. So I would start by adding 9. That's going to give me 2x squared equals 9. Then I'm going to divide by 2. I'll get x squared equals 4.5, right? 9 divided by 2 is 4.5. And then take the square root of both sides, and I'll get x equals plus or minus the square root of 4.5. I can't simplify that because there's no perfect squares that are going to go into 4.5. And then lastly, if I look at number 4, now some of your papers may have had a V here. That's a typo. You can just go ahead and cross that off. But same thing, we want to get the square by itself. So notice only the x is being squared. We want to eliminate these other things. Now, because everything is getting divided by 3, I want to start by multiplying by 3. That's going to give me x squared plus 1 equals negative 5 times 3, which is negative 15. And then I can minus 1 from that. I'll get x squared equals negative 16. Well, if x squared equals negative 16, I can just take the square root of both sides. The square root and squares will cancel, and I'll get x equals the square root of negative 16. Now, the square root of negative 16 is an imaginary number, right? Because it's got this negative. So I need to do a little bit of simplifying here. I can rewrite this as the square root of 16 times the square root of negative 1. The square root of 16, what number squared gives me a 16? Well, that's 4. And then the square root of negative 1 is the imaginary unit I. So I get 4i equals x. And then remember, on your answer, you need to put the plus or minus because positive 4, if you square that, that gives you 16. And negative 4 squared is also 16. So we have plus or minus there as well.